Hello, Geometry Honors. Welcome to Lesson 13.6 on circles. We've studied circles in Chapter 10, and now we're going to put those circles on the coordinate plane. So the first thing we're going to do is look at the equation of a circle. We use the letters H and K to represent the x and y coordinates of the center, and we use lowercase r to represent the length of the radius. And the equation is x minus h squared plus y minus k squared equals r squared. So today we're going to look at a variety of different problems involving circles on the coordinate plane. Sit back, enjoy, and I hope you learned something. So let's take a look at problem number 1. We will find the center and radius and graph the circle. First thing to notice, this says plus 3, so we are using minus 3 for the x-coordinate. This says minus 2, so we are choosing positive 2 for the x-coordinate. We can then go ahead and plot that center. And then from the equation, we know that this is r squared, and we know the square root of 25 is 5. And so now we can move 5 units in every direction, up, down, left, right. And then we can connect them. And there's our circle. Center -3, 2, radius of 5. Let's take a look at problem number 2. This time we know the center of the circle, so automatically we know h and k, and we know a point on the circle. What we don't know is the radius. So we could get started with the information that we do know. With this minus 3, we know our final answer will have x plus 3 squared. With this positive 4, we will have y minus 4, that was sloppy, y minus 4 squared. And so we need a way to find the radius. The radius of a circle is the distance from the center to any point on the circle. So we are going to use the distance formula, which we've been using since lesson 9.5. So 1 minus 3 squared plus minus 2 minus 4 squared. So that becomes 4 squared plus -6 squared. So we get 16 plus 36, which is root 52. And you know from chapter 9, we could simplify that to 2 root 13, but you're about to realize that we don't actually have to for this problem, because what goes on the right-hand side of the equal sign is actually r squared. And so when we square the radius, the radical just disappears, and we get 52. If you were asked for the radius, then we could call it 2 root 13, but for the equation, the 52 is perfect. I'm going to encourage you now to pause the video and spend maybe 3 minutes on problem number 3, and then go ahead and hit play to see if you did it correctly. All right, now that you've had a chance to try it, let's find out how you did. This time we have the endpoints of the diameter, and we're looking for the center, the radius, the equation, and the area. So there's not a single correct way to do this problem, but one option is the center of the circle is the midpoint of the diameter. So we could start with a midpoint, which we did back since lesson 4.1 a long time ago. So we have -2 plus 4 over 2. So we're going to add the x's and divide by 2, and we're going to add the y values and divide by 2. And -2 plus 4 is 2, divided by 2 is 1. Oh, now I'm a little inconsistent. -5 plus 3 is -2, divided by 2 is -1. So we can just put that right over here. And now, just like the previous problem, the radius is the distance from the center to any point on the circle. So you can randomly pick either of the 2 points. I'll just pick this one. And now we can do the distance formula, which will be the radius. So we get 1 minus 4 squared and -1 minus 3 squared. So -3 squared plus -4 squared. So some numbers that you're familiar with, 9 plus 16 gives us 25. And it turns out we have a 3, 4, 5 right triangle. So radius of 5. You could have also done distance formula with these 2 points to get the length of the diameter and then divided by 2. And now, after everything you've seen with the center and the radius, you know how to write the equation. I'm going to zoom in just so it's easier to see and write. So x minus 1 squared plus y plus 1 squared equals r squared, which is 25. And we know the area of the circle is pi times radius squared. And so 5 squared is 25, so 25 pi. And if you felt like doing a decimal, I don't know why you'd want to spend time pressing buttons on the calculator, but you could to get 78.5. So at this point, I hope you feel pretty good about the standard form of our equation of a circle. But now things are about to take an interesting twist. This equation right here is also a circle, and I'm going to expect you to graph it on the coordinate plane. And so what we have to do is transform that equation to match this standard form that we already know. And then guess what? In Algebra 2 and or pre-calculus, you'll actually do this with 3 other conic sections, ellipses, parabolas, and hyperbolas. But this year, we're only going to look at the circles. But there's more to come in your future. It's super exciting. All right, so I put some step-by-step directions on here, and hopefully it helps. So let's see what this looks like. Step 1 says to get similar terms together and move the constant to the other side and leave some space. What does that mean? It means that we want all of the x terms to be together. So the x squared minus 10x. And then we have to leave a little space for some extra work. We're going to get the y terms together, y squared plus 4y. And we're going to leave some space. We're going to move the 13 because the 13 has nothing to do with the process. And I forgot to mention it. It's called completing the square. And so the 13 is going to come over here. But just remember, an equation is like a scale, and it has to stay balanced. So we can't just add numbers on one side, it would be off balance. So whatever I add on one side, I am going to add to the other. And I have this technique, I actually like to just make them look different in case I only have one colored pen or pencil on me. You don't have to do the double lines, it's just an option. So that was step 1. Step 2 says to take half of the first degree terms and square them. So first degree just means the variable is raised to the first power. So here's a first degree term, and here's a first degree term. And so eventually you'll probably just do this in your head, but there's a reason I actually like to have the work written out. So I'm going to take half of -10, which is -5. I'm going to circle it and square it, and that's the special number that we needed, which is positive 25. And that will get added to both sides. We're going to repeat that again. Half of positive 4 is positive 2. And I'm going to always suggest that you keep the plus or minus in the circle. You'll find out why very soon. And then positive 2 squared is positive 4. And so we're going to add that to both sides. And that was step 2 and 3. We squared them and then we added to both sides. So kind of combined 2 steps in one. All right, now it says, step 4 says to factor the left side and then simplify the right side. So here's what we're going to do. The whole reason this process works and the way it got its name. So now we're going to look at these 3 together, and you're going to factor that. Now you have different techniques that you might use to factor. Even if you normally use the box method, you're probably not going to need it here, because if you ask yourself what multiplies to positive 25 but adds up to negative 10, you're going to say, let me get I lost my pen here. Oops, I went too far. Let me fix that. I was trying to get my pen back, and of course, I messed up. And here's my pen. So you could say, well, that's going to be x minus 5 times x minus 5. But the whole reason it's called completing the square is we're going to write it as x minus 5 squared. We found a perfect square. And here's the other real secret. You don't have to stop and factor, because just look inside your circle and you'll already know what goes in the parentheses. Ooh, I found one more little mistake when I was on step number 1. I forgot the plus in front of the y squared. I'm sorry. I'll try to never do that again. All right, and now we're going to factor these 3 together, right? And you could use any factoring technique that you've ever learned. But again, here's the secret. You already know what goes in your parentheses. I guess I'm supposed to be on red. So that is y plus 2 squared. And then now it says to simplify the right side, negative 13 plus 25 is 12, and 12 plus 4 equals 16. And so we did it. Our goal was this. We just did it right here. And so now it says, congratulations, you have a circle with a center at 5, negative 2, and the radius is the square root of 16, which equals 4. So that's your first of many opportunities for completing the square. I'm going to encourage you now to pause the video for just a few minutes so you can try problem number 5. All right, now that you had a chance to try it, let's find out how you did. So same steps as above. We're going to get the x terms together, leave some space. We're going to get the y terms together, leave some space. We're going to move the 11 to the other side. And whenever we add to one side, we have to add to the other side. Now we're going to take half of positive 8, which is positive 4, and then we're going to square it. So positive 16 on both sides. We're going to take half of negative 6 is negative 3. We're going to square it and get positive 9 on both sides. We're going to factor the blue into x plus 4 squared. We're going to factor the red into y minus 3 squared. And we are going to simplify the right-hand side. 11 plus 16 is 27, and 27 plus 9 is 36. So we did write the equation in standard form. And then it says identify the center. So our center is negative 4, positive 3, and our radius is positive 6. So we've seen the standard form equation of a circle, and then we learned how to complete the square to transform it into standard form when it's not given to us. Thank you for watching. I hope you have a wonderful day. You can work on the homework, and we will have one more day tomorrow practicing these awesome circles. Have a great day. Bye.